Alcohols, these contain the hydroxy group, an OH, but they are not basic. And that's because they're not a hydroxide, they are a hydroxy group. So you have a carbon bonded to an oxygen, which in turn is bonded to a hydrogen, but often we ignore that bond when we write it out, and we say it's a COH group. So when you name them, find the parent alkane, that is your longest continuous carbon chain. Number the carbon chain with the lowest numbers possible on the hydroxide group. So start counting from the end closest to the OH. Drop the E from the alkane name and add the suffix number OL, where the number represents the carbon number where the OH is attached to. If you have more than one OH group, let's say you've got two OHs, then you've got a diol, and you have to put in the numbers where each one of those OH groups are. Same if you've got three, it's a triol, and again, a number for whichever carbon those OHs are on. And of course, you're going to name any side groups as prefixes like you would do for any alkane. So the simplest alcohol, of course, would be methanol. So that is one carbon and an OH group. You don't have to specify which number the OH group is on because there's only one carbon. Ethanol. This is ethanol, the second structure, because it has two carbons, so ethane. And we have an OH group, so it's an alcohol. So this is ethanol. Do we need a number for this? If we start counting, this is carbon number 1, because it's closest to the end, containing the OH group. This would be carbon number 2. If I put the OH group here instead, I would just start counting from the other end. So this would also be, if this was an OH, then this would also be 1 ethanol. So ethanol does not need a number. So this is just ethanol. Ethanol is the only alcohol that we can consume. All alcohols are toxic. This one has the least toxicity, but if you drink too much of it, of course, it can kill you. You can get alcohol poisoning. Methanol, you accidentally drink methanol, and you would go blind first before you die. Okay, let's take a look at these structures. Okay, so here we've got the longest carbon chain is 3, as is the longest carbon chain in this one. What is different about these two alcohols is just the placement of your OH group. So in the first diagram, the OH group is on the first carbon. So this would be propan. Take propane and you take off the E. Propan -1 -all. Propan 1-all. Propane 1-all. Propanol. 1 propanol or propan 1-all. The second structure here, the alcohol group is on the second carbon. So this would be prop and 2-all. Propan 2-all or 2-propanol. This is also acceptable. 1 propanol, 2 propanol. Now, because the hydroxy group can be on 2 different carbons, we have to put in numbers for these structures. These two structures are isomers of each other. They have the same number of carbons, the same number of oxygens, and the same number of hydrogens. They differ in the placement of the OH group. You would have to break that OH bond off of the carbon and break the hydrogen-carbon bond to reform and switch the positions. So these are considered isomers, structural isomers. Basically, when you have 3 carbons or longer, you have to have the number indicating where your OH group is. So for this structure, pretend I drew in all my hydrogens. This longest continuous carbon chain is 4, so this is butane. And the OH group is on carbon number 2. So it's butan 2-all or 2-butanol. So let's just move this up and take a look at this next one. Again, I've left off all the extra hydrogens just to make it easier to see. So this structure, find the longest continuous carbon chain containing the OH group. So we could do this way, or we could do this way. We will get the same results. So I'm going to go with the yellow, because it's just easier to read left to right for me. So the carbon chain length is 5, so it's pent, and the OH group is on carbon number 1 when we number these. And you have to continue in the same direction. Always priority goes to the numbering of your functional group. Our functional group here is the OH. So this is pent and 1-all, or 1-pentanol. And the side group is a methyl group. So now you have to put in your side group as a prefix. So it goes out front. It's a methyl because there's 1 carbon, and it will be on carbon number 4. So we have 4-methyl pentan 1-all or 4-methyl 1-pentanol. Drawing alcohols. Identify the longest carbon chain from the root name and draw them out connected, placing all bonds for your carbons. Look at the suffix to identify where the OH group is. Look for the number and add side groups as outlined by the prefix. Okay, let's try 2-methyl butan 2-all. So bute is our longest carbon chain, so that's 4 carbons. We've got a hydroxyl group at carbon number 2, and we have a prefix, so we've got a side group, and it's a methyl group, so we've got 1 extra carbon, and it's on carbon number 2. So draw out your carbons. Bute is 4 carbons. Put in your bonds. We've got the alcohol group on carbon number 2, and we also have a methyl group on carbon number 2. So we've just drawn 2-methyl butan 2-all, or 2-methyl 2-butanol. Physical properties. The OH group is very polar. It has a very polar covalent bond. Therefore, there are dipoles. So small alcohols are soluble in water because they can hydrogen bond with water and they're polar. A polar molecule will dissolve in a polar solvent. As the carbon chain length increases, though, the nonpolar part of the carbon chain, the hydrocarbon chain, prevents the compound from being very soluble. Stronger intermolecular forces are existing in alcohols compared to alkanes. You've got London dispersion forces, dipole-dipole forces, and hydrogen bonding. So their boiling points are quite high compared to their alkanes, and that's because more energy is required, more heat energy is required to overcome those attractive forces. Within this functional group of alcohols, there is a further classification system, and that depends on how many carbons the functional group carbon is bonded to. So there's primary, secondary, and tertiary alcohols. And what that means is that tells you how many carbons the C for the COH is bonded to. In these structures, I've shown you the carbon with the OH group attached in blue to make it easier for you to see. So in this structure on the left, ethanol, this carbon is bonded to only one other carbon, right? There's only one, it's only attached to one other carbon. So this is considered to be a primary alcohol. Primary alcohol. So we can write primary with a 1 to the exponent 0. In the next structure, the COH group is attached to two different carbons. So therefore, it is a secondary alcohol because it's bonded to, that carbon is bonded to two other carbons. And in the last example, the COH, the functional group COH, is bonded to 3 other carbons. So therefore, it is a tertiary alcohol. So the COH, you look at that and you decide how many carbons is that carbon bonded to, and that will tell you if it's a primary, secondary, or tertiary alcohol.